Good morning. Thank you for opening up this video, and please take your time watching it and taking notes from it. This is a really important section with a really important concept that you learned about in the video from Friday. So we're going to jump in and start talking about segment addition. So I'm going to have a segment here, and these are my points. And we're going to call it A, B, C. So the segment addition postulate says if you take the length of segment AB and you add the length of segment BC to it, then you should get the entire segment AC. And that really makes a lot of sense, I hope. If AB is 5 units long and BC is 2, I think it makes a lot of sense that the whole thing from A all the way to C, AC, would be 7 units long, because 5 plus 2 is 7. I'm not going to use either of the examples out of the book, so these are new examples. Let's do another one. This time we're going to take this line and we're going to have a ray coming off the line like this. This is X, this point is Y, and Z, and W. This length we're going to be told is 23. This length is 50. And it says use segment addition to find XZ. From the video, you learned that if you saw something like this, it means the length of segment XZ. That's what that means. So segment XZ, let's just look here. It's all the way from X through Z. Oh, and I should have probably mentioned this little crazy thing right here. My Z's look too much like my 2's if I'm writing really fast. So in order for you to tell my Z apart from my 2, I do a slash through the Z. You've probably seen it before, but if you haven't, this is a Z. Okay, so what is the length of segment XZ? Well, let's break it up. XZ is made of this segment and this segment. So if we put those together, we should be able to find the whole thing. So XY plus YZ will equal XZ. 23 plus 50 will be XZ, and 23 and 50 is 73. So that's the length of XZ. And you might have done that in your head, or you might have written it down. Okay. Let's see. Next example. We have a line with points F, G, and H on it. Please persevere and stay with me through these examples. It is, like I said, a really important topic, and you're going to see it all throughout the year. So you know F to G is 21, and then they have this bracket here, like this. And if you notice, this end point of the bracket lines up with this point for F. Like they line up with each other. And the end point of this bracket lines up with H. So they're trying to show you all the way from F to H is 36. And they want you to find the length of GH. Well, we know segment addition. This part from F to G plus the other part from G to H is going to equal the whole thing from F to H. So it's like one of the parts plus the other part equals the whole thing. So F to G is 21. We don't know G to H, so we can leave it there, kind of like variables. And we know FH, the whole thing, is 36. So you're saying 21 plus what is 36? Or you're solving a little equation. And that tells us that the length of GH must be 15. Okay, this is the last example in this section, and it's a picture of a graph that I took from page 11 in your books. And they ask you in the example to determine whether segment JK and segment LM are congruent. So they want to know, is segment JK congruent to segment LM? That's the question we're asking. Remember from your video from Friday that is the congruent symbol. Since these are nice vertical and horizontal lines, there is no slant to them. This one is nice straight up and down. This one is nice left to right, horizontal. I can just count the spaces, or I can use the ruler postulate. So if you're noticing that these, for JK, let's work with it first. So the length of JK, you can just count the spaces. It's 1, 2, 3, 4, 5. Or since these Y's are the same, that's why it's horizontal, you can subtract the X values. So the absolute value of the subtraction of -3 and 2. -3 and 2 are the values. You can subtract them to get the distance in between them, and you get 5. You get the absolute value of -5, which is 5. So the length of JK is 5. What's the length of LM? Well, LM is this nice vertical line with the same x's. That's what makes it a vertical line. So we can take the y's and subtract them, or we can count the spaces. It's 1, 2, 3, 4, 5 spaces. Or we can take those y values and subtract them. 3 minus -2. That's the absolute value of 5, which is 5. So since they both have the same length, determine whether JK and LM are congruent. We would say yes, JK is congruent to LM. Now that you've seen the video, you should be able to get out your homework and begin on it. Your homework will be page 12, numbers 1 to 29 odd, and 35. I'm going to post a picture of the homework, and I will post it on Google Classroom for you all to use in case you don't have your books.